Welcome. It seems that we are live now. This is a presentation on Bicep as a part of the global Azure conference that's happening right now and running for at least the next 3 days, if I'm not completely mistaken. I hope you found this one through the global Azure site, but if not, take a look at that later on and see the other sessions there as well. But let's get to the actual presentation here and my slides. Just need to get out my PowerPoint. So this presentation is about Bicep. And while these are not my guns that you are seeing at the moment, Bicep will maybe let you grow your own also. I'm Pasi Huuhka and I work as a DevOps architect at Azure. And I've been working as a DevOps expert for roughly 6 to 7 years now. And I have helped to develop and automate stuff for Azure for at least 40 customers so far. I have some certifications and I'm also an Azure MVP. And you can find my stuff on those links. And you can also contact me at any time through Twitter, for example. I'm also an organizer at Finland Azure User Group, which is the largest tech community, at least cloud computing community in Finland. And we have currently over 1.8k members and organize currently these regular 30-minute to 1-hour sessions called Virtual Azure Tips and Tricks. And for more information on those, please find us on Meetup and become a part of the community. Then a little bit about my employer. So Azure has been working on Azure since 2011, and we have a bunch of experts in the community or in the company right now, so 62 out of 67, and they are all very experienced. We also have 4 Azure MVPs in the company, and seeing as there are only 5 of them in Finland, you can maybe understand the amount of expertise here. And this year, or actually last year, we expanded to Belgium. So we finally have a secondary office while our main stuff still happens from Finland. And if you're interested in us, please take a look at our careers site. We currently have a few exciting roles open for Azure. And in general for this session, if you have any questions, please write them in the chat at any point, and I will try to get to them at the end of the presentation. But as an overview, today we'll take a look at what Bicep is and why am I even talking about it and so on. Then we will have a lot of concrete demos on how to actually work Bicep. Most of the presentation is actually about these demos. Then we'll take a look at your questions and I will provide you with a couple of useful links to get started and continue from there. So Bicep, what is this thing? Well, basically it's the next generation of Azure Infrastructure as code. And on the top level, basically is a domain-specific language built on top of the current ARM templates and the Azure Resource Manager API endpoints. And what happens is basically you run a CLI, a build with Bicep build, and it compiles your Bicep template into an Azure Resource Manager template. And this you can then deploy with whatever tool that you want into Azure. And when the solution is like this, it's pretty easy to reuse your previous ARM template tooling to do anything you want after the build to the template itself. So why did Microsoft build this? Mainly to reduce current pain working with ARM templates. So while I feel that ARM templates are very powerful, they can be a little bit hard to learn, and the readability of the JSON files is not the greatest. So the goals were here to also lower the barrier to entry, which I think Bicep does very well. And also this provides kind of a transparent abstraction that still allows you to leverage all the benefits of the platform, and also make it a little bit easier to make your templates modular and remove kind of extra steps that you need to do with ARM to work with linked templates, for example. And then the non-goals, well, this isn't meant to be one language to rule them all. And I kind of agree with that perspective in the sense that whatever tool you're kind of familiar using, you probably can handle your infrastructure requirements with that, and don't necessarily need to be learning something entirely new if all of your employees already know something else. It's kind of the same with any programming language, really. This also is not a general purpose language to meet any need. It's an infrastructure as a code DSL, so its scope is kind of limited still. And while this kind of builds into ARM templates, it also provides kind of a way to somebody else to, let's say, make a better version of this language that people will then flock to, if that ever happens. So they are kind of not locking themselves into anything with this. Then let's take a look at the history a little bit on where is this going, when was this actually released, and so on. So basically 0.1 version was in late last year, if I'm not mistaken, and it had support for primitive ARM template stuff, but not much else. Then version 2 came along, and it had validation for all Azure resource types, as well as IntelliSense module support, code formatting, scopes, so on. So a lot of kind of quality of life stuff already in the language. And today, more like, let's say, a month, maybe 2 ago, we have a 0.3. So the language now has full parity with ARM templates. So anything that you can do with ARM templates, you can do with Bicep pretty much, which kind of means that if you're working with, let's say, Terraform, as you will probably see soon, Bicep is kind of as easy to use or easier, and still provides all the newer resources directly out of the box. Then we also get integration with Azure CLI and PowerShell. We can actually decompile our ARM templates into Bicep directly, so moving it to Bicep is quite easy. And maybe at least somewhat important is that Bicep is now supported by Microsoft support plans, which means that Microsoft also views that version 0.3 is actually production ready. And I do agree, as I've been using Bicep since 0.2 inception, pretty much in production already. Mainly for the reason that it builds into ARM templates, and we can easily verify if they work or not. But let's move into the demo. So let me open my VS Code here. So I just have some notes here. Let's start going through them. So how do we actually install this Bicep tooling, and what does it look like? So basically Bicep has a couple of ways to install it. So like I said earlier, you can get it through Azure PowerShell or actually Azure CLI. So you would go install Azure CLI, and then you automatically get AZ Bicep. Let's see if we can get help here, for example. So we can get AZ Bicep commands here. And as we can see, I have some updates already available, and it says that we can just run AZ upgrade to actually get the newest version. And this is what you can do just to get Bicep installed. The other way of doing this is actually through the repository, so Azure/Bicep in GitHub, and here you can always find the newest versions in the releases. And you have an installer that you can download here. And also you can see all the highlights of the newer versions. And if we take a look at the releases themselves, we can see that, well, maybe tags are easier to see. We get a release maybe once a month or twice a month with some minor updates here. I often end up using this package instead of the AZ CLI to kind of make sure that I always have the newest version here installed on my local machine. Then the other things that we need is a Visual Studio Code extension. So let's take a look at the extensions here. We can just search for Bicep. And this is the one that you want. And this is kind of a key thing to have when you are developing Bicep, as you will soon see. And the intelligence provided by this extension is very good and makes writing Bicep very easy for you. Even if you don't even know what it is, you are very capable with just this extension. So take a look at this one. And lastly, a tool that I will be showing in this presentation is the AZ or ARM-TTK, so Azure Resource Manager Template toolkit. So basically what this does is runs unit tests against the ARM template that we have built from our Bicep file. So we'll take a look at that too. But back to the code. And also you can find all these links in the description of the YouTube video. So take a look at them there afterwards. So now that we have everything installed, we can see that we have the .bicep file here I have created as an empty one, and we have a cool icon on it. So let's start by creating kind of a normal resource that everybody always creates as the first one, so a storage account. And how does this work is actually we just have the resource keyword, and we already get some intelligence kind of examples of how to start writing Bicep. And also we have some kind of examples on specific resources already here selectable. But I'm just going to go with resource keyword. The next thing that we need to give this is an identifier. So this can be anything. So I'm just going to name it my storage. So this is kind of the name of the resource for you, but not really the name that you use in Azure, as we will see soon see. So then we need to select what is this resource. So we can just write storage account, and we get the normal Azure kind of syntax on the resource provider / the resource that we want to get. So let's just take the newest one that's suggested here. We can see that we get all the API versions, even the older ones, if we want to use those for whatever reason. Some of the services do provide you with better intelligence and better documentation on these API versions than others, but it's mostly pretty good. Then we get an equals sign, and we can select some stuff here. I'm not sure why the intelligence doesn't always work, but we can do loops and if clauses and so on. But let's start with the normal resource here. So we instantly get an error, but if we hover here, we can see that our resource declaration is actually missing some required properties. So it kind of knows to get the stuff from this API and knows what is required to actually deploy this resource. So we can just start letting the intelligence do some work. So we instantly get the resources or the properties that we need to set. So let's start with a name. So this like in ARM templates, is the name of the storage account that actually gets created. And I'm just gonna do something here that is globally unique, at least probably. Then we know that we need a kind. We instantly get IntelliSense, gonna check the values that are available. Then we probably need a location. Let's move that up a little bit. And this can be West Europe, in my case. Location doesn't really provide you with IntelliSense, but you probably know those regions already. Then we can say, let's say SKU, that's at least needed. And we need a name, which instantly gets us IntelliSense. We can get a tier, standard also. And lastly, we can take some properties, which could be something like access tiers, at least something I might want to specify, and also then HTTPS traffic only allowed. So now we have a hard-coded storage account, and as you can probably see, the IntelliSense is very good here. Then how to actually build this? So I would go and use the Bicep build command. If you were using the AZ version, you would do AZ Bicep build and so on. And I just give it a name, kind of what is this file that I'm building. And I should get something output here, which is the storage.json, as my file is storage.bicep. And if we take a look at this here, we can see that here's our ARM template ready. We have some metadata here, our Bicep version and so on. But this is the kind of meat here. That's the very simplest way of working with Bicep. But then let's start looking at parameters and variables and outputs. How do we include these here? So as opposed to ARM templates, in Bicep you can actually specify your parameters and variables and outputs anywhere in the file. So if I wanted to, I can do something like this and just start writing parameter, and this could be something like storage name, and I can specify the same things that are in ARM templates. This is a string, and I can then also have an equal sign, what is the kind of default value that I'm giving in here. So let's do it like that, and then I can start replacing here the name like so. So here we can see that I'm pointing to this parameter here. What else we can do with parameters is, of course, secrets. So we get some kind of possibilities here, and this is the way of doing secrets, is kind of adding these decorators to your parameters. So this could be something like my password, and this then builds into something like a secure string, like it does in ARM templates. So if we build this again and take a look at the thing that we get, is that this is automatically a secure string. Of course, we probably shouldn't set a default value for this, but that's here. What else you can do here is actually do the normal stuff for parameters that ARM can do. So what values are allowed, description, max length, metadata, minimum length, and so on. So if you knew that a storage account name is maximum of 24 characters, you could set it here also with these decorators. I personally don't like having these anywhere except at the top of the file, so I'm just going to move these here. But same goes for variables, really. So if we wanted to do variables, we can just write var and even use this template. So it's kind of just what is our name and what's our kind of value for this. So this could be an array of storage names. for example, if you wanted to do multiple in the future. So let's just do storage names. This can be an object, an array, or just a string, or an integer also. And you can also always use the functions that we will be looking at soon in your variables. So let's just give a couple of storage names here. So I'm just gonna copy this one and maybe do something like so. So we have 2 here. That's normal. And lastly, the outputs. So I usually try to keep my outputs near the actual file that outputs them, or the resource that I'm getting the output from. So I can just write output here, and it's actually similar to the parameters. So we get an identifier, and this could be something like my storage access tier. And this is a string. So here we can actually try to get some values from my storage. And this is kind of new to Bicep. So we can do my storage dot, let's say properties and access tier. So what this actually does is that in the background, it creates a reference function for this and gets it already knows what the access tier is here. So we can very easily just point to that here. And if we go back to taking a look at the built version of this, I could actually have it here on the side, but if we go here, we can see that we are referencing the resource ID of this storage name access tier. So as we can see, it is quite a lot easier to write these things in Bicep if we wanted to. Then ternary clauses. So in ARM templates, you can do if equals whatever this logic, but what Bicep brings here is actually being able to create ternary clauses. So you can get one-liners that are much easier to read, basically. So what would we write here? For example, let's do a ternary clause here in the storage name. So we could do something like storage name equals, let's say this. And then we can do, if the storage name is this, we would actually, well, actually this is not the greatest example. Let's make something like this instead. So if our storage name is the thing that we just put here, so this one, we could specify that our SKU name then is standard RS, but if it is not, we can do say standard ZRS, for example. And if we build this now, we can see that we actually get an if equals line here instead. So that's quite powerful also, and quite a lot of easier to read here, in my opinion at least, with this. And this also means that we can do not equals. I think we can also do greater than or greater than equals. So all the normal programming expressions that you might want to take a look at. And for a list of all of these, you'd go to here in the documentation, and I think we have a tutorial on this, and then we have a spec with all the expressions. So we could do multiplication or addition or relational and so on, and or also are available. So this documentation I think is pretty good also on learning how to how to kind of use these. And I think the IntelliSense also lets you know that if you are using the older version or the older functions, it tells you that use equals instead, and lets you know these kind of code smells in that sense. Then we are moving to storage arrays. So we did take a look at the decorators also on the parameters, but those can also be done in a resource copy, actually. So let's just copy this storage account here as another one. And we can see here that, first of all, we need to give another kind of resource naming for this. And this could be something like my storage copy in this case. It doesn't matter as long as you know how to kind of point to it with these outputs. And we can just do copy of this. And if you take a look at the IntelliSense, we can actually do a for loop, a filtered for loop, so we can get an if condition included. And we can also do an indexed for loop here, and also a normal if. So let's do a normal for loop here. So this could be something like storage names that we have here. As you can see, the IntelliSense already knows our variables in this file. And this could be something like account. And then we just need to give the contents of this storage account, or this kind of what is the resource that we are deploying. So I'm just gonna paste it in here, and we can see that we can get this array here of resources in this case. And we of course would want to use the account somehow here. So this could be account, and well, this could be actually something like my storage, or well, this could be account equals like so. So we can kind of point to this same one in the storage name. We could also have an array of objects here, so this would be something like name and then SKU, which could also be object. So this is an RS, and then here being standard. So we could have these kind of objects here, 2 of them. And of course, now we would have the ability to point to account.name here, and also just have this holding as an account.sku. And this way you can pretty easily do multiples of the same resource with your kind of individual configurations, that you only need to kind of specify the things that are important to you in this array. And then lastly, if you wanted to, we could also add here a decorator, so batch size. So normal way of copying stuff in Azure or in ARM is a parallel way. So basically meaning that every account here is kind of generated at the same time. But if we wanted to, we could have a batch size of 1, for example. So it, in serial way, creates one account first and then the second one, and so on. So if you have any kind of need for having this ordering there with those resources, you could do it with this. But I often don't have a need for using this really. Then let's take a look at the if clauses also while we are here. So we could just do here a normal if in front of this. If I'm totally mistaken, perhaps I should. Let's just do this, and take a look at the intelligence. And yeah, it's pretty much what I expected. So what could this condition be here? It could be anything. And this is a way of using this storage name, for example, here. So we only deploy if the storage name is this specific string here. So basically doing conditions in ARM. So if we take a look at the build again, we can see that we have a condition here in the first one, in this location. And then below here, we have a copy loop of the storage accounts listed in our variables storage names. And it automatically does all this copy index stuff for you in the background. Then let's move on. Well, actually, we have an output array here. So we could also do an output array as well as a variable array. So let's just create an output array first. So if we wanted to do an array of copied names, let's say, and this is a string, we could do something like, let's see if we can get any intelligence here. No. So perhaps, if I'm not mistaken, we could do something like account in range storage names. This could work. And then we would have here what is kind of the naming of this specific thing. I actually can't remember the right formatting here, but thankfully I have a sample, so let's take a look. So here's an output array. So we could do for I in range 0 to length of the storage array, and then take a my storage in index something and get its ID value here for storage ID pretty easily. So basically we have an array of storage accounts and we have an array of identities that are provided by it. And this will be an object here with one property ID in this case. But let's move forward here. For the variables, we actually do get some better intelligence for this. So if we did a var of, say, storage names 2, we could just do something like 4 here and 4 index. So this one works pretty well. So if we had another list, we could just have an index and item in the list. So this could be something like item.name, something like this. And then let's see, we have done output arrays and these ones. Let's remove those. Let's take another look at app search plans. So let's start creating one here from scratch, and then see how depends on works between two resources. So this is one cool thing about Bicep is that, as you can see, it does quite a lot of stuff on the background for you, and implicit depends on is one of them. So let's just do an app search plan. So it's a resource, it's an app plan, and this is server forms. This is kind of something that you just need to know, that server forms are app search plans. So let's do a name. This can be my plan. This could be a kind of something I actually don't know, so I'm not gonna use it. Then this could be West Europe, and we could have an SKU of name. I actually cannot remember these, and as you can see, sometimes you do not get the intelligence, and in those cases you then go to the ARM template reference and see what it looks like there. But thankfully I have a sample, so I can just take a look at myself. So we have an SKU of S1 and tier is standard, so let's just copy that one and move on. So here's my app service plan. So now we need to create an app service on it, so something that runs our code. So let's do my app, and this is sites, and we can just write the newest one, and we can pretty much just give it a name, and this could be something like, don't know, it needs to be globally unique, that's fine for us. And we can give it an managed identity, system assigned, we don't need anything else here. And then we could explicitly set depends on, but we don't really need to in most cases, because we could just do, let's say, properties, and here we need to specify server farm ID. And if we do something like applan.id, we can actually get it directly from this app service plan here. We still need to give this one a location at least, so let's do West Europe, and then we should be finished with this. So if we take a look at the build version of this file, we can see that here's our website, and it automatically knows to add this depends on here. So as long as we kind of point to the resource in the same file, we can use that implicit depends on. Of course, nothing really is preventing you from actually just adding the depends on here, like I showed earlier, and it's just an array of stuff. And this could, of course, be the IDs of those different resources. Then let's take a look at the key vault. So as we can see, we are kind of building a somewhat of a application here, which I'm not gonna have time to deploy this time though, but let's take a look at stuff. So we have a key vault. This could be key vault. I often don't use this preview version, so let's see if we have anything else. So maybe that one. And then we could give some name here, location. As you can see, location should be something that you should always give a parameter or variable for, so you don't need to write it for every resource here. And I know that we need a properties of access policies, at least one of them. And here the intelligence is pretty good. It already knows what I need. So we need an object ID, and I know that this is my app.identity.principal ID to get the identity for the managed identity there. And then I can just give a tenant ID, which I can get from subscription function. And also this is the subscription ID, if I'm not mistaken here. Oh, actually no, it's the tenant ID, of course. So like so. And we also get some permissions that are required. So let's give permissions to our secrets for we probably need get and list in most cases, so just use that. You're still missing something, so SKU and tenant ID are missing. So the SKU is something that I, again, don't really have an idea of what it is. So I would take a look at the documentation. but to save some time, I'm just going to take it from here. So we need a standard and A. So going back here. And then lastly, we need to give the tenant ID again. So we can again do something like subscription dot tenant ID. So here's our key vault. Then we need to get a child resource, or a secret, to actually add to the key vault. So how Bicep does this is a little bit different from the kind of default way of doing it in ARM. So in ARM templates, you would have this resources array in this kind of resource to have sub resources, and the objects get very long once you have a lot of sub resources there. Of course, you can do this same way that Bicep works in ARM templates too, which I think nowadays is almost the preferred way of doing this also there. But let's see what we have here. So we have a child without default, so let's do that. So we can see kind of the formatting here directly. So my identifier is just a secret, but we can see here that we need a provider name, we need the parent type, and then the child type at version, so at API version. And once we have the key vault here, we already know the provider and the parent type, so we could paste it here. And then the child type we would need to figure out ourselves. So I know that I want a secret now. So in this case, I just find it easier to just write in secret here, and I get instantly the direct pointer here to the full string that I need. So something like that. And for child resources, we need to give in the name of this key vault as the first kind of section of this naming. And then we need to give it a slash and the name of the secret, just like it's in the resource kind of format here. And this can be done pretty easily in Bicep. So in Bicep, we can do string interpolation pretty easily. So this is the format to use. So a $sign and curly braces. And here we can just do the identifier of our resource. So it's key vault. And let's see what we have here. So API version, ID, name, properties, tags, type, whatever. So we need the name. And as we saw in the earlier example, we actually get this depends on automatically from this. So I can just do a slash, and then I need to give in the name of the secret. And I'm just going to give in a variable, so secrets name being my secret, something like this, and then we just do secret name. And again, we of course need these to kind of get anything outside of the literal string here. So something like this. And then if we wanted to, we could get the value of the secret. So let's see, properties value. So let's actually get the value for our storage account connection string. So we can see how the secret functions kind of work here. So let's just give this a better name here. So it's storage connection string. And the value here would be just, in this case, well, let's see actually if we can get it from here easily without doing any of this function stuff. So my storage dot properties dot let's see, we might not actually get this from this. I can't actually quite remember. So it's maybe not in properties. So it seems that we cannot get it directly from here. So what we do is use any of the functions that are found in ARM templates. So one of these is list keys. And while I did not get direct intelligence for this, that I believe is because this list star function doesn't really point directly to those list keys. But for this, we need the resource name or identifier as a string. Then we need the API version. And then we need function values if there are any. And then once we have this, we can just do dot something to kind of see what's inside the returned value. So let's try this out. So we needed the API version, or actually the name of the resource. So I'm just gonna do the storage name, not storage name, it's my storage in this case, dot ID. So I get the exact identifier here. Then I need to get the API version. This is also quite easy to just do my storage dot API version. And then I should be pretty much ready with this. So from this list keys, I could then do dot and get the values that I require here. And for this, I would probably take a look at the list keys documentation from the ARM files. I'll actually show this to you. So I'll just do ARM template list keys and get to the template functions. It's maybe this one. And from here, I can just search for list keys. So take a look at the documentation here required, and we have the implementations list here for the storage account. So let's scroll down a little bit. Storage accounts, list keys. And here we can then see what the response is. So we can see that we have the sample response here, and it would be something like dot keys in position 1 or 0 actually, dot value would be to get the primary key for this. So you cannot get the direct connection string directly from the storage account. You can do the storage account key, and you would do some string interpolation to get the kind of connection string here instead. But this would be something like, let's see, keys 0 dot value. So like keys 0 dot value, and this would get us kind of the storage account connection string key we could use. All right. Then we have a couple more things here. We have 10 minutes left. So let's try to work through this. So modules is one thing. We can actually do a new file here. So main.bicep. It could be anything we want. But what is a module? It's kind of the same thing as a link template in ARM templates or a module in Terraform. You can pretty much just do a module here, and we need to give it an identifier. So this could be my app, and then we need to give it kind of a direct path to, or relative path to, our Bicep file, that is our module. So any Bicep file is pretty much a module. And then we can just do the same loops here as we did before. And basically we can give a name, and this is a name of the deployment kind of, so my app deployment, whatever is visible in the logs of the deployment in your kind of Azure portal. Then we can do parameters, so it knows automatically what are my parameters in the file that I specify here. It also knows what are kind of the required parameters. So if one of these didn't have, say, the my password, for example, here at the top didn't have a default value, we get an error showing that my password is missing and we need to give it in. So this is quite intelligent this way. And let's just give in some value here. And lastly, we can do a scope. So like in ARM templates, we can specify a scope of some resource group. Actually, can't remember the exact syntax here, but we can specify a resource group like resource group this, or we could specify a certain subscription at this top level here. So we could have a target scope of management group, resource group, subscription, and tenant for the whole deployment, and so on. So all the same stuff that you can do here can be done. Or what can be done with ARM templates can be done here also. And what does this look like when we build it? So let's do main.bicep. So we basically get resources here, and it's just a Microsoft resources/deployments object, which has kind of our template that we specified in the file inside it. So this is how they get around the requirement to, for example, store your ARM templates in a storage account before deploying following templates. So this kind of compiles everything into a single file. But let's see what else did we still have here. So the storage. Yeah. Then the CI/CD part. So how do you actually deploy these? Well, it's an ARM template that you get out. So you can just run, let's say, new AZ resource group deployment, for example. Or you can run AZ deployment group create to deploy that. Or you can then just actually nowadays call the Bicep file directly with those commands. So deploy storage.bicep, and it knows to kind of build it directly as part of the deployment process itself. But I'm going to deploy this right now. I will rather show you how this is done in the CI/CD part. So this is an example of a CI/CD version or a pipeline in Azure Pipelines. And the only thing I need to change in relation to my normal ARM template deployment is actually installing Bicep. This is at least how I do it. It might be that the tasks in Azure DevOps, for example, have already updated to versions of Azure PowerShell and this Azure CLI that would allow me to directly just use the same deployments. But for now, I have just done it so that I just do an invoke web request to a certain Bicep version from GitHub and put it in my tools directory. And then I just run this against my main file, which specifies all the modules that I want to deploy. Then I run some tests with ARM-TTK, and I skip some tests that have been a problem in the past for some dumb reason. Then I just publish the test results, and then I just run validation in this case. So this is a validation step, but if I wanted to do here complete or incremental, it would actually deploy these to my resource group here. So this is fairly simple to do, as if you have done anything with ARM templates before, at least in that case. But here, as I'm talking about ARM-TTK, let's actually see how that works too. So I have built the storage.json here. I could actually pull the ARM-TTK repo here, which I have done. And then I have done an import module command here from my local machine and import the PSD. These instructions are in the repo also, so take a look at that. and then I actually get a test AZ template command, and I'm just testing my main here. So if I run this, it kind of runs unit tests against my ARM template, and it knows what resources are in the ARM template itself and specifies these as, or looks at these tests with what it needs to run based on that. And all of my tests pass, but these are kind of the best practices. I think Microsoft uses these same unit tests themselves. So while this TTK tests extension is created by Sam Kogan here, you could set this up yourself and make sure that it uses the latest tests from the repository. But in our perspective, this has been so easy to set up that I have just used this in my pipeline myself. And it kind of helps you to notice issues as quickly as possible. Then lastly, let's take a look at the decompilation part. So as I mentioned before, ARM templates can be decompiled to Bicep. And this can be done with, let's do Bicep help first. It's a little bit bigger. So we have some options here. One of them being Bicep decompile. So let's take a look at that. It doesn't have help, but let's see what this does. So yeah, we kind of just need to give in our ARM template name. So I'm just going to rename this to something else, storage something, and decompile this. And we just basically give a JSON file here. And as the warning says, the decompilation is a best effort process. So some things might not decompile, or they might decompile kind of not perfectly. So this is basically just a tool to get you started. So as we can see, we get a Bicep file, and we can actually see that some of these identifiers have changed, and they can be pretty hard to read in some cases. But most of this does work for just the small amount of resources that I have right now. But in most cases that I have tried this, it's been quite a lot of red in the console, and I have had to basically go through the resources individually still to see kind of what is wrong there and how could I fix it. But it does save you a lot of time not having to write everything again. Yeah. So I think this is a great tool, and at least a great beginning on getting people to move to Bicep faster. But we still had one more thing here. So the playground and links and so on. So if you want to test Bicep, there's this playground that has the latest version often of the Bicep packages, and you can basically have a Bicep file here, and it automatically compiles into an ARM template, so you can basically test something. Let's just add another parameter here, so it automatically should at least give me a variable here that I could use. And you can also do the decompilation here by uploading your ARM template. And we can also take a look at the samples. So just like in ARM templates, you have the quick start templates. So most of those have been already modified to Bicep by the community. And these can also be found in the Bicep repository, or you can take a look at them from this playground here. So we can just click here and it loads this as a Bicep. Clearly they are not perfect, considering there are some file pointers here that are not present in the playground. But basically you can take a look at these from this playground, or just go to the Bicep repository. And this can be found in docs, I believe, examples, and here are the folders. Have all of these separate levels of Bicep templates that you can get started with. But let's come back to this in a second and take a look at the last slides. So I think that the takeaways here are that the syntax is quite simple. It's much easier to use than ARM templates, in my opinion at least. It's easier to test and develop with the module pattern. It's production ready, so you should test it out. And the decompilation process helps you get started. And why I feel that I would rather use this than, let's say, Terraform is that, well, it gets all the features as quickly as possible, as well as I don't need to manage the state myself, because Azure does that. And that I have felt that with Terraform, for example, it has been quite a bit of a pain kind of manually or self-manage the state of the resource group. Of course, that might have changed in the recent year also. But then the resources and links, some of these we already looked at. There's good documentation in the repository. They also have a 7-part tutorial that you can take a look at, and sample templates. Then we have the playground, and lastly I just have my blog. I have not yet written anything about Bicep there, but you might find something else there, and I'll try to write some more in the future. But next up, if you have any questions, please write them in the chat, and while you're doing that, I will also show you a little bit on the tutorials here. So Bicep docs, there's just basically how to create a simple template, how to deploy, how to use expressions, symbolic resource names, looping, creating modules, and so on, and also converting ARM template. And these have been written, I felt that these are very good and have good examples on how Bicep actually works. And as you can see, GitHub now supports syntax highlighting also for Bicep, so this is a good thing also. But what else? Not much at the moment actually. So let's see if we have any questions in the chat. Not yet. Let me check this out also. Yeah. All right. So hopefully you guys have had at least some learnings from this talk, and you can find the slides, maybe a bit of an older version of them, here in azure.li/pasi/bicep. There are also some examples there, the ones that I showed you briefly. And basically I would take a look at the official repository as kind of the biggest thing. But all right, thank you guys. If you have any questions in the future, feel free to contact me in Twitter or LinkedIn or whatever, and have a great Global Azure conference. Thank you.